Okay, sorry, I forgot to introduce myself because we have to do it at every session. Hello everyone. My name is Malik Arslan Nisar and I am a TA for this course, Numerical Linear Algebra. And today we are in the week 6 of the course. And today's live session, we will be discussing some problems related to the content you have studied during the week. So here on my screen, we have the first question. Is my screen visible?
Yeah, it's
Okay. So, which of the following inequalities is true when x belongs to Rn? So, below are given some certain inequalities which we have to check whether they are true or not. So, the first is that Euclidean norm of x is less or equal to under root n into infinity norm of x. Then the second is infinity norm of x is greater or equal to 1 norm of x. The third option is that 1 norm of x is less or equal to Euclidean norm of x. And the fourth option is Euclidean norm of x is greater or equal to root n into x, infinity norm of x. So, can you tell me which of the following options or following inequalities holds true? Because you have gone through this content during the week.
clear norm of 2 is less than or equal to root 10.
Less than or yeah,
Yeah,
this one holds true.
yeah,
So we will check each of them one by one
yeah.
and we will see which one is correct. So for the first one, what is the definition of Euclidean norm? We know that it is nothing but under root of the summation
Yeah,
I running from 1 xi square,
yeah,
correct?
yes,
And we can say that this thing is less or equal to if we take summation of I equal to 1 from 1 to n xi and then take its whole square. Do you agree on this thing? If we have three numbers, say 1, 2, 3, and we in the first case we are doing 1 square plus 2 square plus 3 square, it's coming out to be 1 plus 4 plus 9, that will be 14, right?
yeah.
But in the other case, if we add all the three, first 1 plus 2 plus 3,
6 square.
which is 6, and its
Yeah,
square is
36.
36. You must have been gone through the proof of this also, but for getting an intuition of these things, we can do it on actual numbers for the understanding purpose. So see, here also you can see that this thing is definitely going to be greater than this, right?
Yeah,
So this equality holds true. And this is nothing but what? It is
this.
one norm, correct?
Yeah,
This is the one norm for x. Now, from the definition of infinity norm, what do you understand from infinity norm? Infinity norm of x. It is nothing but the maximum value if we
of
are
6.
taking, yeah,
Modulus,
yeah,
magnitude.
the maximum value of xi, correct?
Yeah,
And let us suppose that we found out this maximum value. It's going to be some number in the x, right?
yeah,
Maybe x2, maybe x3, maybe x4, or so on. So let's call it arbitrary xk. It is some xk, which is the norm of the x, which is the infinity norm of the x. Now, since we have assumed that, let's call that norm, in the infinity norm of x, let's call it as xk. We know that this xk, if like, sorry, the mod of xk raised to power p, and we can take its root 1 over p, right? We can do this.
Yes.
It's the same thing.
Yeah.
Now we know that this thing is less or equal to what? If we take xi to the power p and I running from 1 to n, and then take its 1 by p, similarly as we did here, right?
Yeah. Yes. Yes.
This thing is going to be
Yeah.
greater than, like this thing is always going to be less than this. See how, if we have a number series given c1, suppose the values of x are 1, 2, 3, 4, so on 6, right? Up to say 6. Here xk is going to be 6, correct?
Yeah.
But xi to the power p raised or 1 by p, that will we have to do with all these numbers, right? Say suppose p is 1 1 in this case, then 1 plus 2 plus 3 plus 4 plus 5 plus 6, it's definitely going to be greater than this thing, right? Definitely going to be greater than 6. That you
Yeah.
can understand by intuition also. So so this we arrive from here. And next, what we say, this thing is nothing but what is this? P norm, right?
P.
It is P norm of x.
Yeah.
So from here, it implies that infinity norm of x is less or equal to
P.
P norm of x. This is the second result we arrive at. Now, coming to the options, here we have been
Yeah.
given a
Now
comparison.
it's greater than
Yeah,
transforms.
comparison of this Euclidean norm with the infinity norm. So we can quickly calculate it. See, if we have been given the p norm, and now we know p norm is nothing but summation of I running from 1 to n xi to the power p root over 1 by p. And since this thing is true for a single x k, then if we are taking the summation of xi, then each of those xi's is definitely going to be like less or equal to this thing, right? See,
Yes. Yes.
x1 is less or equal to xk to the power p. Then x2, that is going to be less than this, right? So if from here, in this case, I is running from 1 to n, here also we can take n, the xk n number of times, right? Since you know that xk is the maximum among the series or the vector we are being given,
So
xk is
x1
the
to the
maximum.
power 3 it's less
Sorry.
than or equal to x1 to the power p plus like that.
Yeah, see, if it is given, consider we are not taking xk, in this case it is x1 to the power 1, sorry, to the
Yeah.
power p. Say p is equal to 2 in our case, correct? This is x1 square plus x2 square plus x3 square. We know that x1 square is going to be less or equal to xk square.
Yes.
x2 square is going to be less than this, x3 square is going to be less than xk square, x4 square is going to be less than xk square, because the k is the maximum value. Now on the what we say left hand side, we are adding all xi's, and on the left right hand side we are taking xk, that many number of time. So definitely the right hand quantity is going to be greater than the left hand side, right? Greater or equal to. So from here we arrive at that this thing is nothing but n times xk to the power p root over by 1 by p. I am making it for p norm so that we can generalize it. If here we are given x3, x2 only, but I am taking it for the general case. So, yeah. From here, we know that it can be written as this thing is less than. n to the power 1 by p, then x to the power, sorry, x, no, xk, the magnitude of xk. And we know that this thing is what? Magnitude of xk is what? We defined it here. It is the infinity norm of x, right? So we can substitute it with the infinity norm of x. And now on the right hand side, we had what? P norm. So here we arrive at this conclusion that P norm of x is less or equal to n to the power 1 over p into infinity norm of x. Now in our case, put p equal to 2. So Euclidean norm is going to be less or equal to the infinity norm. Correct?
Yes.
Do you agree on this thing? And this is the first option. So from here, the first option is correct. Now look at the second option and tell me why it is not correct. It is given that infinity norm is greater or equal to
In
the
one
one norm.
now, one now.
You can easily
Substitute
disprove
is
it by
yes.
just taking an example. Like in this case, the infinity norm is going to be what? 3? Correct. But the one norm is going to be 1 plus 2 plus 3, that is 6. So this is disproved here only, right? Now similarly, third also, third we showed here only, right? That x2 norm is less or equal to x1 norm. And here it is given the reverse, right? It's given x1 norm is less or equal to. So this option is also
Wrong.
wrong. And last option is just the opposite of first. So if the first is correct, last is wrong. Okay. So do you need to note down anything? Or should we move ahead?
We'll move.
Okay. Take a moment, then we'll move to next question. Okay. So the second question we have is that let x is equal to a1 2 transpose. It is a vector which belongs to R3 with the x2 norm is given, it's root 20. Then what is the value of a? Please calculate it fast. It is very simple. Tell me the value of a. What is the value you're getting for a?
Root 15.
Plus or minus root 15.
Yeah.
Okay. So this
Yeah.
is was very simple. It's nothing. We know that Euclidean norm is a square plus 1 plus 2 square,
Root
right?
of
Root of
yeah.
this thing, and it is given to be as root 20. Now squaring on both sides, a square plus 1 plus 4 is equal to 20. So a square is 15. A is plus minus root of 15. Correct?
Yeah.
So this was simple again. Is this color visible? Like, is this
Yeah,
color
it's
fine?
okay. Okay, okay.
Okay. So now moving to the third question. This is a previous year assignment. So I thought it the like previous year questions are very much relevant to your assignments.
Yes.
So
The
that's why
pattern will be almost same.
yeah. So consider the sequence xn x to the power n, where xn is defined as n upon 2 to the power n, then 1 plus 1 upon 10 to the power n, and e to the power minus n cos n, then xn converges to, yeah. So the options given are half 1 0, the second option is 0 1 0, the third option is 0 1 by 10 minus 1, and the fourth option is 1 1. So this is the question that you have been given a sequence, right? And
Yeah.
you have to find out to which value does it converge. So how will you do it? What do you mean by the convergence of vectors? You know that given a sequence xk belonging to r to the power n, like rn, limit of this k tending to infinity, xk, in our case k is replaced by n. This means, like, this is how we find where the vector converges, right?
Yeah.
We tend k to infinity and we find the value of we find the limit value of xk at that point, and we say that the whole vector converges to that point only, right? To this, like, to that vector only. So you know that if xk converts if xk converts to certain point, when we are tending k to infinity, then each of these individually will converge to the same vector, right, at infinity. So what does that mean? That means that all of these will individually, when n tends to infinity, they will converge individually to the components, right? Suppose this xk is converging to a vector x1 x2 x3. So we know that this thing, when n tends to infinity, it will converge to this x1, this thing will converge to x2, and this thing will converge to x3. So that is what we have to find, like v1 v2 v3, you can give any name to this. So this is what we have to find. So it's nothing, you have to take limit n tending to infinity on each of these and tell me what you are getting.
1
0 1 and
0 0.
yeah, that is correct. When doing limit on this thing, we'll use L'Hopital rule, and you know that on the exponent, limit n tending to infinity gives 1 over limit, this gives infinity, and the whole thing will become
0.
0. Now doing it on limit n tending to infinity, 1 plus 1 over 10 to the power n, this one, it will remain the same. Then 1 over 10 to the power infinity
Plus
will again be, this thing will be again
1.
infinity, it will be 0, so it will be 1.
1.
And in the third option, limit, sorry, in the third one, e to the power minus n into cos n. You know that cos n has a
Infinity.
bounded value from -1 to 1, right?
1.
It will
Yeah.
oscillate between that only. So we can ignore this thing because it will oscillate between these two. Then e to the power minus infinity, we know it is equal to 0. So it means that this sequence, when k, or sorry, when n tends to infinity, this sequence tends to this vector only. Understood?
Yeah.
So this is the correct option. Um, Now, moving ahead. Let V equal to R and B a real inner product space with inner product U comma V given by I running from 1 to n ui vi. It's nothing but the definition of inner product. And let u is equal to under root of x1, under root of x2, so on up to under root of xn, and v is equal to 1 upon under root of x1, 1 upon under root of x2, 1 upon under root of x3, so on up to 1 upon under root of xn belonging to v. Then uh, then you have to find the value of summation of xi, I running from 1 to n, multiplied with summation of I running from 1 to n, 1 upon xi is greater or equal to what? This is an inequality. You have to find its like value, what it is going to be greater or equal to. So like how will we do this question? Do you have like, can you get the approach for this question? Like, how will you approach this question? Anyone?
We'll expand in the series. And apply that that inner product rule.
Yeah, you can do that, and then if you see by doing the inner product, you will get 1 plus 1 plus 1 time n times, and that will be equal to n. Then what about this inequality? I will tell you two ways of doing this question. One is very basic, you have seen that from the class 11, 12, and the another you have I think you have, you must have read it in the lectures. Do you know about the Cauchy Schwarz inequality? Do you know what it says? Gifty? What is it equal to? It says that the inner product or dot product of two vectors is always less or equal to the norm of u vector and the norm of v vector. Like if
Yeah.
we usually
Yes.
multiply their
Yes.
norms,
Yeah.
I made it a mess. It is going to be greater than this value, right? Now you can clearly see that while taking the inner product on the right hand side, right here, we are going to get n. It is equal to like under root of x1 upon x1 plus under root of x2 upon x2 under root of x2 plus so on up to under root of xn upon under root of xn, right? On the left hand side, let's keep it the same for now. Now here again, this thing is going to be 1 plus 1 plus 1 up how many times? N times. And it is going to be less or equal to this quantity, that is norm of u into norm of v. Now again on left hand side, this thing is n, and from right hand side, what is the norm of u? We can say that norm of u, Euclidean norm, is under root of summation of I running from 1 to n
X.
x,
Sorry.
it's given root xi, so root xi square is what? Xi, correct?
Yeah.
This thing. And similarly, what is the norm of v? Norm of v will be summation of root over of summation of I running from 1 to n,
1 by
sorry,
X by
1 by
minus
xi, correct?
1 by, yeah.
1 by under root of xi whole square, that is 1 by xi. Now squaring on both sides, n square is less or equal to summation of I running from 1 to n, xi, summation of I running from 1 to n, 1 upon xi. So this thing is greater or equal to what? N square. Understood?
Okay.
See, while doing any question, you first have to look at what the question is asking. If you could, like by inspection, you would understand that this thing is nothing but the norm of u, right? And this thing is nothing but the norm of v.
V.
Then you can understand, yeah, it is talking something about norms, and then it's also talking about the inner product, which is clearly observed, like we can clearly observe that the inner product is equal to n. So there must be something which is relating the norm and the inner product. That is how you approach a problem, because in exam there can be, the concept has been taught, but the problem can be such that you will have to think that how I approach this problem, because the steps are very easy, right? So that approach you have to develop. See, we can do it in another way also. You know that here, if you see, u has been given as under root x1, under root x2, so on, and under root xn, right? And similarly, v has been given as 1 upon under root of x1, 1 upon under root x2, 1 upon under root x3, and so on. So this tells us that, we can write method 2. This tells us that all xi's are positive, like greater than 0. Correct? And we know for any positive sequence, the, like you can find the arithmetic mean and the harmonic mean, right? What is the arithmetic mean for any sequence?
Summation by n.
Summation upon
Yeah.
n. Now we know that for any positive sequence, the arithmetic mean is always going to be greater than the harmonic mean, correct? Since all xi's are greater than 0, so am is greater or equal to gm is greater or equal to hm. So right now we focus on am and hm only. Arithmetic mean is this thing, and geometric, harmonic mean will be what? N upon 1 upon x1 plus 1 upon x2 plus 1 upon x3, so on up to 1 upon xn. This is how we write a harmonic mean for a positive series. And from here, by cross multiplying, you can say this summation of xi from I running from 1 to n, and this is what? Nothing but summation of 1 upon xi, I running from 1 to n. You just cross multiply it from here to here, and on the left hand right hand side, it will be n square, right?
Yeah.
So this is also how you can approach this problem. But since we are studying vectors, so this thing will be a better approach. So noted till here?
Yes.
Okay. So, okay, the next question is you have to do it by yourself. The question is for the function f of x equal to cos x, find x for which this function is, find x which implies f of x is ill conditioned. You know how to do this?
Finding the condition number, then
Yeah.
we'll
You have to find the condition number and then you can, the greater the condition number, the function will
to
be ill
be
conditioned. Do it fast and tell me what the value of x will be.
x is 0 means it is well conditioned.
Yeah. If no, if condition number k is coming near to 0, that means the problem is well conditioned. If
Yeah, that
condition
x
number
should
is
be 0.
tending to infinity,
Then it will be around pi by 2, it will be going to infinity.
yeah, if cos x is coming out to be 0,
Yeah.
then x will be what? Odd multiples of pi by 2,
Yeah.
right?
Yeah.
So for finding the condition number k, what we do?
Yes. X
The,
into f dash of x by f
yeah,
of
f
x.
dash of x upon fx.
X.
Just a
Yeah.
second, someone is joining. So f dash of x upon f of x divided by x, right?
Yeah. That
And
is
that is coming out to
minus
be
x tan
sine
x.
x upon cos x by x, correct?
Yeah, minus, okay,
Yeah,
okay, yes, yes, not
x sine
x.
x by cos x.
Yeah.
Now,
Tan
for this
x.
function to be ill conditioned, we know that k should tend to infinity, and for that cos x should be implies cos x is equal
Zero.
to 0, which
Yeah.
implies x is equal to 2n plus 1 pi by 2. Understood?
Yes.
Okay, so now similarly we have another question. If f of x is given to be e to the power x square divided by x, this function is well conditioned for what values of x? So try to do this question.
X. This is assignment question, ma'am. It is
Oh, this is
x
assignment
plus or
question.
minus, yeah, 1 by root 2.
Okay, so that this question has been repeated, I guess,
Yeah.
because this is in previous year assignment as well. So let's quickly do this then. The solution is simple. Again, k is what? F dash x
Actually, 0. Okay, it should be near to 0.
upon f of x divided by x, right?
Yeah.
Now, what is f dash x? It is coming out to be, uh, wait a second, x into e to the power x square into 2x minus e to the power x square upon x square whole divided by e to the power x square and this divided by x. So taking e to the power x square common, it will be 2x, uh, so this is here, 2x
Means
square
next
minus 1 upon x square whole divided by e to the power x square upon x, right? This and this will cancel.
one x also will.
Yeah, 1x is here. Yeah, while differentiating, 1x will come out as well, and yeah, that also cancels, right,
Yeah.
with this thing,
So 2x
and it
square
comes
minus
2x
1.
square minus 1. Now here the question is that it should be well
Well
conditioned.
conditioned. So
For
it should be
well
0.
conditioned, this should be 0
0.
or close to 0. Now
Yeah.
here we have the option of taking it as 0, then x square is 1 by 2 and x
And
is
x is
plus
1 by 1.
minus root of 1 by 2. Okay,
Yes.
so what about others? Ronak, have you attempted these questions?
Yes, ma'am.
So you were able to solve them?
Yes, ma'am.
Okay. Yeah. Now look at this question. Consider a machine with 5 decimal digit floating point. Consider a machine with 5 decimal digit floating point rounded arithmetic and then consider the sequence xn defined recursively. So the recursive expression for xn has been given recursively by xn plus 1, which is equal to 3n plus 1, 3 to the power n plus 1, multiplied with 1 plus x power n upon 3 power n minus 1, comma n equal to 0, 1, 2, so on. And x naught has been given with x naught equal to 0.01. Then using better way to avoid the cancellation error in the given iterative scheme, the second, find the value of x3. So if you have noted down this, have you noted this down?
Yes. Yes.
Yeah. So what the question says that consider we are operating with a machine which has a 5-digit decimal system, with 5 decimal digit floating point rounded arithmetic. That means what? Beta is 10, it uses decimal system, and t is equal to 5. That is, it rounds off to 5 digits, right? And then it's asking that, then it's telling to consider a sequence which is like a recursive sequence given by x n plus 1 is equal to 3n plus 1 multiplied with root over of 1 plus x to the power n 3n divided by 3n minus 1. Like this thing, this expression, it is the recursive expression, and this machine is like working on using this expression and calculating values of x0, x1, x2, x3. And you know that since we are dealing here with a negative number, like a negative sign here, minus 1, there is a chance that in the subsequent iterations there will be a cancellation error, right?
Cancellation.
Because of
It's
subtraction, because you read in the past week's lectures that
yes.
due to subtraction there arises cancellation errors,
Yes,
not due
yes.
to addition or multiplication
Mm,
or division, but due to subtraction there the error is increased. So this question is asking us to find a better way to solve this so that the cancellation error is not there. Now since it's asking us to avoid cancellation error, we know that what we have to avoid is that the negative signs in the expression, right? Anyhow we have to try that this minus 1 should not be there.
yeah.
So think of a way in which you can do this, how we will like make this expression like with only positive signs. Multiply by root something plus 1. Yeah, yeah, that is correct. You will multiply and divide the term which is given here, this under root of 1 plus x power n upon 3 power n minus 1. You will multiply and divide with uh, the same thing with plus sign. Let me do it here. So x to the power n plus 1 into 1 plus x to the power n upon 3 power n minus 1, and multiply it with 1 plus x to the power n divided by 3 to the power n plus 1, and also divide it with the same. Correct? This we can do, multiplying and dividing by same thing. So this thing will change to what? 3 power n plus 1, and this will be a square minus b square. So a square is 1 plus x to the power n upon 3 power n, and what is b square? It's
One.
1. And whole divided by under root of 1 plus x power n upon 3 power n plus 1. Now see, here the negative 1 goes, and now the expression we are getting is x to the x n plus 1 is equal to 3n plus 1 into x n upon 3n divided by under root of 1 plus x n divided by 3n plus 1. Here this 3n will cancel this 3n plus 1, it will, there will remain only 1 3. So 3xn upon under root of 1 plus xn by 3n plus 1. Now quickly calculate the value of x3. You know how to do it. X naught is given. You will put n equal to 0. So that will be x1 is equal to 3 into x naught upon, it's not x to the power n, it's xn, the nth term. So it's xn. Okay. Here also, please don't consider it as x to the power n, it's xn divided by 3 power n. Again xn divided by 3 power n. Anyone calculated the value of xn? Sorry, x1. Tell me fast. What is the value of x1? It is coming out to be 0.014963. Now, what is the value of x2? Because the question is asking for x3. So we have to calculate x2, then we have to calculate x3. Tell me the values what you are getting. Calculated anyone? Guys, fast.
0.022416.
Yeah, x2 is 0.022417. That is correct, Gifty. And what is for the x3? Others also try to find it fast. If you keep on practicing this, it will help you in exams because your calculations will be like good at that time and you won't make much error during the examination if you are doing it now. If you skip and say like ये तो simple calculation है, we will do it later, then that might create a problem later. So try to
0.014.
0.014.
Yeah.
I think there you are making some mistake. The correct answer should be 0.033605. Is anyone getting this answer? Other two people can confirm as well. So you might have made some little mistake.
Yeah.
Check this. This one is the correct answer. So should we move ahead? So, oh, I think there is some question. Comment in chat. Okay, how to see well condition for this recursive function? See, Moti, this is a condition number is basically defined for a problem, not for an algorithm. This is basically an algorithm. In condition number, what we are specified to find is that we have been given a function and we know that its roots are say 1 and 2, like the input is 1 and 2 and we get the answers, we are giving input 1 and 2. Now the condition number tells us that if I fluctuate the input a little bit, if instead of 1 I give it 1.001, and instead of 2 I give it 2.002, something like that, like minor changes in input, how will the function respond to it? How will the problem respond to it? If there is a large fluctuation or large change, like I give a small error in input and there is a large error in output, we say that the function is not well conditioned. So that is the conditioning. Now this is an algorithm. In algorithm, what we are trying to do is that iteratively we are trying to find different terms or of this sequence, right? Now to check in the case of algorithm, uh, the analogous term, like we find the stability of the algorithm, that the algorithm should be stable. It should not show much fluctuations or oscillation. And for checking that, what we do, you do nothing but, if in this case also, without changing it, we had been given this equation. So you do nothing, you put the value of n equal to 0, then n equal to 1, then n equal to 2, and so on, and find the values you are getting, right? If in like, if the output you are getting, it is showing a trend of monotonically decreasing trend or an increasing trend, so you say that this algorithm is stable. But if there are fluctuations, like the the value should be decreasing after a certain period of time, you notice, yeah, this function, it should be decreasing, it should tend ultimately to 0 as I increase the value of n, and it should tend to 0. But such is not happening with the values. In between you get a positive value, a large value, or in between you get a negative value, and then again you get small values. So that is, you have to manually find out that. And maybe in this case I have not found it, maybe at 11th term or 12th term you can see that fluctuations, and then you say that this algorithm is not stable. And for reducing those cancellation errors or to make it stable, then we perform other operations. Like here we eliminated this one because we thought that the cancellation error might be coming from this only, because this is the negative term, so we will eliminate it. That is how you check for this. Understood? I hope that answers your question. Okay, so should we move ahead, others?
Okay.
Yeah. So the next question is, hmm, Okay. Solving the quadratic equation x square minus 184.36x plus 1.7979 is equal to 0 by a machine with 5 decimal digit floating point chopped arithmetic. If the exact roots are x1 equal to 184.350247 and x2 equal to 0.0097526 315, then by avoiding the cancellation error, the relative errors for the roots are given by. So the question is that you have been given a quadratic equation x square minus 184.36x plus 1.7979 equal to 0. So this is the quadratic equation you have been given, and uh, so the like you have to solve this equation with a machine which has the decimal digit floating point chopped arithmetic. What does that mean? Again, beta equal to 10, t equal to 5, and you have to use chopped representation,
Yeah.
right? Now from
Yes.
that machine you are calculating the roots, and you have been given the exact roots, and now the question is telling that if you are avoiding the cancellation error, then what are the relative errors in the roots? So how will you do it?
That is finding x star by rounding, the chopping up
Yeah,
to 5 decimal digits.
yeah,
X1 star.
you have to simply find the chopped representation for this,
Yeah.
and then subtracting
I
that
mean,
from
like,
the relative
yeah,
error, the
relative.
formula you have been
Yeah.
given, right? X1 star
Yes.
minus x1 upon x1, it will be relative error in the first root, and in the second root the relative error will be x2 star minus x2 upon x2,
Yes.
where the x2 is the original root and x2 star is the chopped arithmetic root you are getting from the machine, right? So quickly do this and tell me what you are getting before we
That
discuss.
X1 star is, because it's a 5 digit machine,
Yeah,
184.35
yeah.
with chopped.
Uh-huh.
Then X2 star will be
Uh-huh.
point 00975526.
0.009756. Yeah.
And then RX1 is 1.3420 10 power minus 6.
Uh, okay.
RX1.
Yeah, I actually got it something like 1.33 into 10 to the power minus 6, but yeah, that
Yeah.
is almost same.
RX2 is 3.2298.
Yeah, correct. So then let's do it quickly. You know that EX1 is going to be x1 star minus x1 whole divided by x1, and it is 184.35 minus what is x1? it has been given that the original root is 184.3502474,
3, 5.
okay, and whole divided by 184.3502474, correct?
Yeah.
And now when we calculated, the value of x1 ex1 is coming out to be 1.33 into 10 to the power minus 6. So that is the relative error with x1. Now in case of x2, that is the second root, it is again going to be x2 star minus x2 upon x2, which is nothing but 9.7526 into 10 to the power minus 3 minus 0.00975, sorry, 52 is it, right? 526315 whole divided by the same number, and it is coming out to be 3.2998 into 10 to the power minus 6. So these are the errors associated. Was everyone able to solve it? Should we move ahead?
Okay.
Okay. Now the question here is the linear system 2.0001525 x1 x2. Let me write it here.
I think this is on an assignment question.
Oh, this is assignment question. Yeah, this might also be repeated. So yeah. So the you have been given a linear system, okay? It's a 2 cross 2 matrix. A say Ax equal to B. It is of the form this, right? So you have to comment about it being ill conditioned, well conditioned, neither of the above, or it cannot be solved.
Yeah. Actually, we have to find that condition number, that is norm of A into norm of A inverse. That will
Yeah,
be the condition number.
correct.
So it comes to be ill condition because
Okay, so you
A
have done it
inverse,
already,
yeah.
right?
Yeah.
What about others? Can you tell me what is the condition number you got, Kavita?
Kavita madam is not
Sorry,
there.
not Kavita, Gifty. I'm sorry.
Yeah, it's a big okay.
Can you tell me what you have gotten? How do you find norm of J, Gifty?
Then I did it now too.
How? Others have done it.
No, ma'am.
You have not done it. Okay. Okay. Anyways, we are going to discuss it. So, do you know how to find the norm of a matrix? Anyone? See, for finding the norm of a matrix, say A given as 2, 0, 0, 1, 5, 2, and 5, and uh, yeah. So what we do that for the matrix we find a unit vector, right? We find a unit vector and we multiply that with this matrix and then we maximize the value. What is basically the meaning of norm is how much the matrix is able to stretch a vector. What does a matrix do? Basically, matrix is a linear transformation. It maps vectors from one space to another. Say Ax is equal to B. So x is a vector on which the A operates and it transform it into B. Now B can be greater than what x was. Say the values of x were something 1, 2, 3, and then we get the values of B. So the values of B or the B can be a vector which is longer than the previous vector or which is more stretched. So norm is basically the finding the norm of a matrix means how much it is able to maximum stretch, because it will stretch different vectors differently. So the maximum it can do is known as a norm. So what we do, the procedure to find the norm of a matrix is that we multiply it with a unit vector, and after that we find the, like, we maximize that. There are like steps. First, what we do, say for A I calculate AU, where U is a unit vector. Suppose uh, I will tell you later what we are going to take U. So U is a unit vector and we find AU. After finding AU, we take its norm, and that is equal to what? Max of AU upon magnitude of U. So this you have to remember, you have to take it, and after that you have to do the same thing for A inverse. When you find A inverse, you have to do again this thing, and then you have to, what you are getting out of this, you have to multiply with that of A inverse and you get the norm for this matrix. So अभी अगर समझ भी नहीं आया, as we will proceed, as we will do, you will understand. So the first step, I told you that you have to multiply it with a unit vector. So the unit vector, what will we take the unit vector as? Gifty, since you have done it, what have you taken this u equal to?
No, actually, I did in the math lab. I told no first I could no, I used MATLAB
Use
function.
MATLAB.
MATLAB, yes, I
MATLAB is finding in MATLAB is very easy. You just have to
but
write
I
the
got
condition, right? Condition of this
yes,
matrix, and
norm
then
of it will come. Whatever norm it will give.
no, in MATLAB you can find directly the condition number as
Yes.
well. You can just put
And that I didn't know did it. I did only the
okay,
norm.
okay. See, because in exam you'll have to do it manually. So,
Yes, that I know.
or any or. No, see, that is for a specific. You can take a specific value, but we will not take a specific value, Moti, because we have to do it in a generalized case. So we will take such a vector, suppose cos theta and sine theta. It will work here. We will take cos theta and sine theta because we know that cos square theta plus sine square theta is equal to 1. So this is a unit vector. But yeah, so we will take this only. Okay. So now what will be the value of AU? It will be 2.001 cos theta plus 5 sine theta.
Zero. One more zero is there. 0.00.
Oh, that is triple zero. Sorry, yeah. It is, um, wait a second. Sorry. It's 2.0001 cos theta plus 5 sine theta. Okay. And the second will be 2 cos theta plus 5 sine theta. Right.
Yeah.
Now, what is the norm of AU? Quickly tell me. It will be 2.0001 cos theta plus 5 sine theta whole square, right? Plus 2 cos theta plus 5 sine theta whole square. Correct? Now, what is the norm of A? Norm of A is maximum of norm of AU upon norm of U. Now, since U is a unit vector, so the denominator will be 1. So, you have to do max of. So, you have to maximize this thing, norm of AU. Okay. So, how will you maximize it? First, we will simplify it. This is A plus B ka whole square, right? So, it will be 2.0001 square cos square theta, right? Plus 25 sine square theta plus 2 into 2.0001 into 25, not 25, it will be 5.
Sine theta.
Into 5 sine theta cos theta, correct?
Yeah.
Then the second term will be what? 4 cos square theta plus 25 sine square theta plus 20 sine theta cos theta. Is it correct?
Yeah.
Or maybe did I make a mistake? Okay, it's fine. Now here it will be equal to 8.00040001. I am clubbing this cos square theta and this cos square theta. Okay. So it will be something like this into cos square theta plus 50 sine square theta. This 25 sine square theta and this 25 sine square theta will give me 50 sine square theta. Now the third one is 20.0005 sine theta cos theta. Okay. No, it will be
40 points.
40, no? Yeah. It will be 40 point. What it will be? 40 point?
001.
Okay. 40.001, right?
Yeah. Yeah.
sine theta cos theta. Okay, so now look here, cos square theta can be written as 1 plus cos 2 theta divided by 2, right? 8.00040001, and this thing can be written as 1 plus cos 2 theta upon 2, and sine square theta can be written as what? 1
1
minus cos
minus
2 theta divided by 2, and this thing can be written as twice sine theta cos theta is what? Sine 2 theta. So I'll write 20.001 sine 2 theta. Understood till
14.
here? No, it's not
Uh,
14 because 2 I took here,
yes,
na
yes, yes,
twice.
yes, 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 yes.
Yeah. So as you simplify it further, it will be 4.000075 plus 25 plus yeah, 4.000075 minus 25 cos 2 theta plus 20.0005 sine 2 theta. Everyone got till here? Now this is the magnitude of J. So finally it is coming out to be 29.000075 plus this thing. Now look here. What is I told you earlier that here when you are finding the norm of AU, sorry, the norm of A, you have to maximize this AU, correct? So for maximizing AU, you know that if there is a term like A cos theta plus B sine theta, what is the maximum value of that? A cos theta plus B sine theta. Because see this thing here 29.0075, it's constant. What is going to be variable or changeable, that is this cos 2 theta and sine 2 theta. So since you have to maximize Ju, what will be the maximum value of this?
9 point.
Hmm?
The constant value will be maximum
Yeah, but what is it equal to?
root of
Root of, yeah, if you have a cos theta plus b sine theta, if you have an expression like this, then the maximum value is going to be under root of a square plus
is
b square. So this will be under root of, when you calculate this 4 point this minus this, it will be 20.9999925 square plus 20.0005 whole square, this square ka root over. So that will be the maximum value of norm of Ju. So tell me what it is coming out to be quickly. Calculate it fast.
7.0026.
Yeah, close. I have a slightly different value. What about Moti and Ronak? What are you getting out of this? So it will be 7.6158. Okay, this is the value you are getting for this. Now, wait a second, I change it. Here it's not J, it's P. So norm of A is what? The maximum value of the norm of AU. Okay, which we found out in this case is going to be 7.6158. Now, similarly, you have to find the
Of A inverse.
for A inverse, the norm of A inverse. Okay. So, quickly tell me what is the norm of A inverse. First, tell me what A inverse is. Quickly. Find out A inverse. It's a 2 cross 2 matrix. Find out the A inverse and tell me what the A inverse is.
25 to 10 power minus 4
Uh-huh.
and 5 minus 5 minus 2, 2.007.
Is it correct? Because I am getting a slightly different matrix. Is it something like 1 minus 1 minus 0.4 into 10 to the power 4?
Okay, okay, I didn't multiply inside. Then I'll get like that.
Okay. So try to do it manually. Don't use MATLAB or calculator. See, you can use online calculators and that
Yeah,
will be helpful, but during the exam, you won't be able to use them, right?
yeah.
So
It's
try to do these calculations manually. That's why they are giving simple matrices in questions like 2 cross 2 matrix so that you can easily find the inverse as well. Others are getting this value. Okay. Now find the norm of A inverse. In the similar way, that is maximum of A inverse into U. Again, you have to multiply it with cos theta, sin theta, like I did this procedure. Quickly do it and tell me what you are getting because I'm not going to repeat the steps again. That won't make sense. So I have shown you in one part, next you will do yourself. Quickly find the maximum value of this thing. You have, I'll give you 5 6 minutes you can take and try to find it. Anyone got the answer? Yeah, Murthy. And it is 10 to the power 4 also multiplied with it. What about Ronak and Gifty?
What are you doing?
Yeah. Moti, have you joined the session for the first time? I did square root by calculator. Moti, see, there is no fast way because you have to like follow this procedure only because finding norm is what? Just finding the Euclidean norm is nothing. You have to take the square root of the components, right? Of the like components of the vector. You have to take the square root, and in most of the cases there will be cos and sine terms, and you know that to maximize them simply you have to make it in the form of a cos theta plus b sine theta, so that you can take under root of a square plus b square. In case of like since it was a 2 cross 2 matrix, here you use this unit vector cos theta sine theta. But if it were a 3 cross 3 matrix, that time you would have to use unit vector like cos alpha cos beta cos gamma, such that cos square alpha plus cos square beta plus cos square gamma is equal to, and in higher order matrices it will change. So I don't think in your exams there will be like more than a 3 cross 3 matrix. I think that will be the maximum, even if it will be there. So by practice only you can do it. There is no short trick for this thing. You have audited this course. Okay, so you're from which college? Are you like what course you're doing right now? If you can unmute yourself. Okay.
It's 1.1523 1510.4.
Yeah, correct. And Ronak, did you get the answer? Ronak, are you getting the same? 1.5232 into 10 to the power 4? If yes, then good. If not, then you can recheck maybe if you are making a mistake somewhere. So the condition number for A will be what? Norm of J into norm of, norm of A into norm of A inverse. I have done it on my notes as J. That's why I'm making this mistake. So it is coming out to be what? Quickly multiply it. 7.6158 into 1.5232 into 10 to the power 4.
11.6.
It is coming out to be 1.16 into 10 to the power 5. So you can see that the condition number is huge, right? The condition number is very large, so it is an ill condition. Okay. Now one more question is there.
Yeah.
Based on q is equal to 1 1 1 plus u1 1 minus u1, and d is equal to 2 and 2 plus u2. Okay, this has been given, and what we have to find? Find the norm and condition number of q in terms of u1 and u2. Okay, that is the first part. Then the second part is at u is equal to 0.01 and u2 equal to 0. Yeah. Find the norm of q and its condition number. Okay, first you have to find the norm in terms of u1 and u2. Yeah, and then you have to find the norm and condition number when u1 is given as 0.001 and u2 is given as 0. And the third part is, how does this solution change as a result of very small changes in u1 and u2 around these values. So the Q matrix has been given, D matrix has been given, and the system. The linear system is Qx equal to D. Okay. So the linear system is Qx equal to D, and for this you have to find the norm and the condition number. So first, how will we do part 1? Find the
No.
norm. The norm of Q will be what?
No. Maximum of QU.
In order to find the norm of Q,
Max.
first
Now.
we will consider again the unit vector, right?
Yeah.
So we consider the unit vector as again cos theta, sin theta, because it is a 2 cross 2 matrix. Then finding QV, which is equal to what? 1 1 1 plus u1 1 minus u1 into cos theta sin theta. So tell me, what is the norm of QV equal to? QV you will get from this, and for norm you have to take QV is coming out to be what? Cos theta plus sin theta. Okay, and it will be 1 plus u1 into cos theta plus 1 minus u1 into sin theta, right?
Yes.
Now what is the norm? Okay. Now the norm of QV is what? Under root of this thing, cos theta plus sin theta whole square plus 1 plus u1 cos theta plus 1 minus u1 sin theta whole square, right? Wait a second, let's not here. Whole square. So you can simplify it along with me. Okay, it will be under root of 1 plus u1 square into cos square theta plus 1 plus 1 minus u1 square into sine square theta plus 1 plus 1 plus u1 into 1 minus u1 twice sine theta cos theta. Okay, now this thing will be again 1 plus u1 square cos square theta, then 1 plus 1 minus u1 square sine square theta, and yeah, plus 2 minus u1 square sine 2 theta. Again substituting cos square theta with what? 1 plus
Cos 2
cos 2
theta.
theta by 2, and substituting sine square theta with what? 1 minus cos 2 theta divided by 2. So I'll write it here for your reference. Cos square theta, put cos square theta equal to 1 plus cos 2 theta divided by 2, and sine square theta as 1 minus cos 2 theta divided by 2. Now tell me what this expression is coming out quickly. Simplify it and tell me what you are getting. Root of u1 square plus 2 plus root of u1 square plus okay, wait a second, let me check the chat box. Root of u1 square plus 2 plus root of u1 to the power 4 plus 4 here to the power 4. Yeah, some okay, yeah, that is correct. That is correct. What about others? So that is the norm you are getting, right? The maximum value of it. Others also try to solve it quickly. See, this will become something like 2 plus u1 square plus 2 u1 cos 2 theta plus 2 minus u1 square sine 2 theta. Now again this thing 2 plus u1 square will remain as it is. This cos 2 theta and sine 2 theta, this term you can maximize. So the maximum of this thing, let me call this as f of theta because it is a function of theta. So the maximum of f of theta will be what? As I already told you, it is under root of 2 u1 square plus 2 minus u1 square. Sorry, it's u1 square ka whole square. Okay, it's 2 u1 square and plus 2 minus u1 square whole square. That will be the maximum value of f of theta. Okay, now as you simplify this, it will be 4 u1 square plus 4 minus u1 to the power 4, correct, plus yeah, 4 u1 square and plus 4 u1 square. I think I made a mistake sign.
Plus u1 power 4.
It will be something like this: 4 u1 square plus 4, then minus 4 u1 square and plus u1 to the power 4. Okay, and this thing is nothing but u1 square. You can take common here, and it will be 4. This will cancel this, and it will be u1 4 plus u1 to the power 4 root of. Okay, so this is the maximum value you are getting out of this. So now, what is norm of q again? It is the maximum value of qv, right? And it will be equal to under root of what? We had
2
here
plus
this
u1
2 plus u1 square, right? 2
plus
plus
u1
u1
plus
square, and then this thing. Okay, under root of 4 plus u1 to the power 4. So this is the norm of q. So you got till here. Now,
yeah.
what will be the condition number? For finding the condition number, what we have to do? We have to first find we have to find q inverse, right? To find the condition number k of q, we have to find norm of q inverse, right? So can you quickly find norm of q inverse? It's simple. Again, you have to do the same thing. Take your time and try to solve this. First, q inverse will be what? If anyone has calculated, help me here. Tell me what q inverse is. Q inverse will be minus 1 by 2 u1 into 1 minus u1 minus 1 minus of 1 plus u1 and 1. This is q inverse. Now second step is what?
Finding now.
Finding q inverse into v. Yeah, that is how you find norm, right? First find this thing, then maximize it. So quickly tell me what is the value of this, or even if you are getting the norm simply.
Kada daran. Sorry.
That's fine. When you're not speaking, that time you guys can mute yourself. So I will leave this as a homework to you. You can find q inverse v because it will take time and we do not have much time left. So I will give you the expression of this, and then please tell me what is the norm. I'm giving you the expression of norm of q inverse v, that is u1 square plus 2 upon 4 u1 square. Okay, do it at your own end and check if you are getting the same. And the second will be 1 by 4 cos 2 theta minus 1 upon 2 u1 square sine 2 theta. Okay, now for this thing to be maximum, Again, what? This thing, let me call it g of theta. We called it f of theta earlier. Okay, I think my screen is gone. Okay, wait a second. Is my screen visible?
No, madam.
Okay, wait a second. Is it visible now? Yeah. So, huh. So when we are maximizing this, we are getting something like under root of u1 to the power 4 plus 4 upon 4 u1 square. Okay, when we are maximizing g theta, this is the maximum value. Then putting it in here, then q inverse into, wait a second, q inverse into v ka norm will be equal to under root of, sorry, max of q inverse v ka norm will be equal to u1 square plus 2 plus under root of u1 to the power 4 plus 4 upon 2u1. Now since we have gotten this, which is nothing but norm of q inverse, okay, now what is the next step? Finding the condition number. So what is condition number? It will be norm of q into norm of q inverse. Now at least this you can calculate quickly and tell me what you are getting the condition number as. You have to multiply these two things. Under root of 2 plus u1 square plus under root of 4 plus u1 to the power 4 multiplied with u1 square plus 2 plus under root of u1 to the power 4 plus 4, okay, whole divided by 2u1. Okay, so the condition number is coming out to be u1 square plus 2 plus under root of u1 to the power 4 plus 4 divided by 2u1. Okay, this is the condition number we are getting. Note it till here.
Yes, yes.
Then move ahead. Okay. Now condition number we have found. What was the C part of the second part of the question? That at at u1 equal to 0.01 and u2 equal to 0, find the norm and its condition number. You just have to substitute these values. Quickly do this and tell me what you are getting. So the second part is for u1 is equal to 0.001 and u2 equal to 0. Okay. Norm of q will be what? Tell me what you are getting the value of norm and of condition number. What is the value of norm? Anybody calculated? It will be 2.000025, and that I have substituted here divided by this, and the condition number is 200.005. Noted till here? What about Ronak and Gifty? Should we move ahead? Are you guys understanding what we are doing here? So, okay. Now for the values of u1 equal to 0.001 and u2 equal to 0, we have found out the norm of q as well as the condition number of q. Okay. Now the third part of the question, that how does this solution change as a result of very small changes in u1 and u2 around these values. So it is basically asking us, if the u1 and u2 are changed, how will this solution change? Okay, so we have to basically check the dependency of this solution on u1 and u2. Okay. So how shall we do it? Any idea? How will we do this thing? Okay. So let's do this part quickly. Here we have x equal to x1, x2, right? Which is of the form 1 plus 1 by 2 u2 by u1 and 1 minus 1 by 2 u2 by u1. Okay. Now x1 is what? 1 plus 1 by 2 u2 by u1. What we have to find? We have to find the change in x we are getting when we change in any of the two, u1 or u2. So we will differentiate this thing. So del x1, which is the partial differentiation, is will be something like this. You can try it on your own and tell me if I am wrong. So u1 del u2 plus u2 del u1 upon u1 square. Okay. Because the differentiation of 1 will be 0. So this term we are differentiating, it will come out to be something like this. Now look here. When u1 is equal to 0.01 and u2 is equal to 0. Since the question is asking us about the values near these two things, like u1 and u2. values close to 0.01 and 0, it is asking us how the solution will react. Okay, so when u1 is 0.001 and u2 is 0, put these values here. What we are getting the value of delta x, it will be 1 by 2 into 1 upon 0.01 delta u2, and it implies del x1 is equal to 50 del u2. Okay, so see, here you can see that change in x is insensitive to u1, so it only depends on u2. If you are bringing changes in u2, this is going to be sensitive to that. For u1, it's not going to be sensitive, because in the del x1, you're not, in this expression you're not getting any term of u1. Okay, now similarly for x2, we know that from here x2 is what, 1 minus 1 by 2 u2 by u1. Okay, this thing. Now taking del x is equal to what, del x2, it is coming out to be minus 1 by 2 u1 del u2 minus u2 del u1 upon u1 square. Okay, now del x2 for u1 is equal to 0.01 and u2 equal to what, 0. We are getting the value of del x2 is equal to minus 1 by 2 into 1 upon 0.01 del u2, which is coming out to be minus 50 del u2. Again, you can see that this is also depending on only del u2 and not del u1. So the change, the delta x is something like 1 into minus 150 del u2. So if you bring small changes in u1, the solution is insensitive, like the solution will not change. But for the case of delta u2, even small change is multiplied 50. What does the yeah, the condition number tells about that the solution is in like, since the condition number was coming out to be huge, uh, basically, let me tell you, put it this way. For say, yeah, here we found out condition number for what, u1 and u2 only, right? And the condition number was coming out to be 200, so it means that condition number is a huge number. So that means this system is ill conditioned. Okay, ill conditioned close to these values, we are getting that. But the question was asking us, this condition, this system will be insensitive, like this condition, this system will be ill conditioned, because even if any of the x1 or x2 we are changing, it is like giving a big change, not in case of u1 but in case of u2 it will change. So the condition number tells us that thing only, that yeah, that this system is ill conditioned, because that was 200, so the condition number should not be much greater than 0. So that was greater than 0, it means close to 200. This condition, this system is ill conditioned. But the third part was asking itself that we have to separately comment about u1 and u2, about the changes that u1 and u2 will give. So for that thing, condition number will not tell us which input is going to give the change. That's why we did the third part, to find how it depends on u1 and u2. So from this part, we understand that the ill conditioning of the system is because of u2, not because of u1. Because for the changes in u1, the system remains insensitive, but for the changes in u2, the system is sensitive. Even a small delta u will give a magnification of 50. So that is the purpose of the fourth part. Otherwise, the condition, third part or the condition number itself told us about the system, that whether it's ill conditioned or not. Okay. a second. Yeah, exactly. So, uh, yeah. So, understood till here? This is only the solution because here we had to comment about the delta x and its dependency on u1 and u2. Okay, so the last part is that for the changes of u1 it is insensitive, and for the changes in u2 this system is sensitive. Okay, so I think it's already late, so we should end the session, or if you have any doubt or questions you can ask. And if you have skipped anything while noting down, I will upload these in
No.
the presentation folder. Okay, you have the access to that, right?
Yes.
Okay, okay. So, goodbye, good night, and see you in the next session.
Next it will be Friday, madam.
Yeah, next will be most probably it will be Friday.
Okay.
Okay,
Okay.
okay,
Good night, madam.
okay, goodbye. Some resources regarding understanding of matrix norms. Um, I think you have the NEPTIL lectures on this, na, which the course you are doing. Other than that, I think. Uh, there are some books which you can go through, like uh, Krasik is there, and then there is another book known as Applied Mathematical Methods. It's by Bhaskar Das Gupta. You can refer to that, and and yeah, and for understanding, there are some good channels on YouTube also. If you have to get like the if you want to know the significance of matrices, vectors, and everything, I would recommend a channel, 3 Blue 1 Brown. You can go through his lectures on linear algebra, so that will give you a clear understanding of these things. Okay.